Explaining why living standards vary so much around the world is in one sense very easy, because the answer can be summarized in a single word: productivity. Okay, what is productivity? It is the average quantity of goods and services produced per unit of labor. Maybe it's not complicated to you, but let's make a simple example. And in our example, we are going to talk about Robinson Crusoe economy. And Robinson Crusoe is a sailor stranded on a desert island. Because Crusoe lives alone, he catches his own fish, grows his own vegetables, and makes his own clothes. We can think of that Crusoe's activities, his production and consumption of fish, vegetables, clothing, as a simple economy. By examining Crusoe's economy, we can learn some lessons that also apply to more complex and realistic economies. What determines Crusoe's standard of living? In a word, productivity, the quantity of goods and services produced from each unit of labor. If Crusoe is good at catching fish, growing vegetables, and making clothes, he lives well. If he is bad at doing these things, he lives poorly. Because Crusoe gets to consume only what he produces, his living standard is tied to his productivity. In the case of Crusoe's economy, it is easy to see that productivity is the key determinant of living standards, and that growth in productivity is the key determinant of growth in living standards. The more fish the Crusoe can catch per hour, the more he eats at dinner. If Crusoe finds a better place to catch fish, his productivity rises. This increase in productivity makes Crusoe better off. He can eat extra fish, or he can spend less time fishing and devote more time to making other goods he enjoys. So productivity's key role in determining living standard is as true for nations as well as for Crusoe. And like Crusoe, a nation can enjoy a high standard of living only if it can produce a large quantity of goods and services. Americans live better than Nigerians because American workers are more productive than Nigerian workers. The Japanese have enjoyed more rapid growth in living standards than Argentinians because Japanese workers have experienced more rapid growth in productivity. And hence, to understand the large differences in living standards via browse across countries or over time, we must focus on the production of goods and services. But seeing the link between living standards and productivity is only the first step. Now we need to look at why are some economies much better at producing goods and services than the others. So we will look at the determinants of productivity. But going into details of the determinants of productivity, I want to mention a couple of symbols we use. We use the letter Y as the real GDP, quantity of output produced, and letter L, the quantity of labor. So the productivity in mathematical terms can be written as Y over L. And let's now look at the determinants of productivity and input rate. The first one is physical capital per worker. So recall that the stock of equipment and structures used to produce goods and services called physical capital and denoted by K. First, let me clarify what is a physical capital. For example, when woodworkers make furniture, they use saws, lathes, and drill presses. And more tools allow the woodworkers to produce their output more quickly and more accurately. A worker with only basic hand tools can make less furniture each week than a worker with sophisticated and specialized woodworking equipment. As you see, the physical capital refers here the tools that the woodworker is using. If you recall from the previous chapters, the inputs used to produce goods and services like labor, capital, are called the factors of production. An important feature of capital is that it is a produced factor of production. So here the source is a produced factor of production. That is, capital is an input in the production process that in the past was an output from the production process. For example, the woodworkers uses a lathe to make the leg of a table. Earlier, the lathe itself was the output of a firm that manufactures lathes. The lathe manufacturer in turn used other equipment to make its product. Thus, capital is a factor of production used to produce all kinds of goods and services, including more capital. Okay, as we said, it's symbolized by K, and for determinants of productivity, we need to look at how many capital, physical capital per worker. So we are going to look at how many tools and physical capital a wood maker has. Productivity is higher when the average worker has more capitals, machines, and equipment. And an increase in this per labor, the amount of tools, increase in the tools per labor causes an increase in productivity, which is per labor how many output is produced. The next one is human capital. Human capital, what is human capital? The knowledge and skills workers acquire through education, training and experience, and it's represented by letter H. And H over L represents the average worker's human capital. What are human capital? Human capital includes the skills accumulated in early childhood programs, grade school, high school, college, and on-the-job training for adults in the labor force. Education, training, and experience are less tangible than lathes, bulldozers, buildings, but human capital is like a physical capital in many ways. Like physical capital, human capital raises a nation's ability to produce goods and services. Also, like physical capital, human capital is a produce factor of production. Producing human capital requires inputs in the form of teachers, libraries, and student time. Indeed, students can be viewed as workers who have the important job of producing the human capital that will be used in the future production. Okay. Human capital is very important because with human capital, workers gain the skills to be able to use the tools, which is the physical capital. So there is a really important connection between these two. You need to have the ability to be able to use the tools that you need to produce more goods and services. And the third one is natural resources per worker. Natural resources are symbolized by N. What is natural resources? The inputs into production that nature provides, land, mineral deposits. And per worker, again, the determinant is not the natural resources, but natural resources per worker. Okay, there may be some natural resources, but it may not be enough natural resources per worker. So if there is an increased natural resources per worker, that means the amount of natural resources per worker cause an increase in the productivity, which is Y over L. And we can divide natural resources in two categories, renewable and non-renewable. For instance, a forest is an example of renewable resource. When one tree is cut down, a seedling can be planted in its place to be harvested in the future. Oil is an example of non-renewable resource. Because oil is produced by nature over many millions of years and there is only a limited supply, when the oil is depleted, it's impossible to create more. And differences in natural resources are responsible for some of the differences in standards of living around the world, like the example of Saudi Arabia. Saudi Arabia is rich in oil and it creates maybe some living standard differences between the country because Saudi Arabia has a lot of natural resources. But natural resources are not necessary for an economy to be highly productive in producing goods and services. Japan, for instance, is one of the richest countries in the world despite having few natural resources. International trade makes Japan's success possible, so Japan imports many of the natural resources it needs, such as oil, and in return exports its manufactured goods to economies rich in natural resources. And the fourth one is the technological knowledge. What is technological knowledge? It's the understanding of the best ways to produce goods and services. 100 years ago, most Americans worked on farms because farm technology required a high input of labor to feed the entire population. Today, thanks to advances in farming technology, a small fraction of the population can produce enough food to feed the entire country. This technological change made labor available to produce other goods and services. Okay. Technological knowledge takes many forms. Some technology is common knowledge. After one uses, everybody knows it. But some technology is proprietary, like Coca-Cola company. For instance, Coca-Cola knows a secret recipe for making its famous soft drink. But here, it's very important to distinguish between the technological knowledge and human capital. Okay, all very closely related. There is an important difference. Technological knowledge refers to society's understanding about how the world works. And on the other hand, human capital refers to the resources expended transmitting this understanding to the labor force. To use a relevant metaphor, technological knowledge is the quality of the society's textbooks, whereas human capital is the amount of time that the population has devoted to reading them. So workers' productivity is depending both of them, both the technological knowledge and the human capital. Let's write all together this all four determinants into one function. So the production function is a graph or equation showing the relation between output and inputs. As we know, what are the inputs for production? Labor, capital, which is physical capital, tools, equipment, human capital, the skills and training of the worker that he can be able to, he can use the tools for production, and the natural resources. Okay, F here, as you see here, F is the function, symbolize a function that shows how inputs are combined to produce output. As you see, I didn't talk about technology. Technology is not inside the function. It's a constant next to the function. A is the level of technology, and A multiplies the function F. So improvements in technology, increases in A, allows more output to be produced from any given combinations of inputs. So you can easily write all these things together, what we learned, into one simple equation, so that we can be able to represent this, all this what we learn about productivity, into one single graph. Next, you are going to see some concepts for the production function. You don't have to understand these parts very well, because it's actually an advanced level of using the production function and constant returns to scale idea, but the definition is very easy. If you change all inputs by the same percentage, and if the output changes the same percentage, then you can say that your production function is constant returns to scale. So what does that mean? Let's say you want to make a cake, okay, and you put one labor, you yourself, one baking oven, and 2 eggs, maybe 1 pound flour, and you mix all together and you make one cake. And for making 2 cakes, as you see, double the amount. If you double the amount of the inputs, like 2 labor, 2 baking ovens, 4 eggs, and 2 pounds of flour, then you will have a constant returns to scale production function. Okay. And here, from production function, we can come to determinants of productivity. How? Just we are going to divide every variable on this side by L, so we will get per unit, per labor. As I said, productivity is per unit of the labor, how much output a labor can produce. So if you do that, you will see that the productivity, determinants of productivity, can be here written in a single equation: K over L, H over L, and N over L. So the determinants of productivity, including also A here, the level of technology, physical capital per worker. How many tools each worker has, not the total amount of tools in the economy. It's very important, because we may have a huge amount of tools, but per person we don't maybe enough. If you divide among the labor, maybe you don't have enough physical capital per worker. And the next one is human capital per worker. The same idea. Maybe you have education, but not everybody can get this education. Then it's a problem. It's not going to affect the productivity. Productivity is human capital per worker, and the same is true for natural resources per worker. The only difference is the technology, because technology can increase any inputs. If you have a technology can increase any combination of inputs for the production function.